Okay, in this section, we get to talk about variables and different types of data. So the first thing we're going to talk about is the difference between qualitative and quantitative variables. Qualitative variables are categories, so hair, color, gender, type of car you drive, anything that can separate you into categories. Quantitative variables are numerical, so anything that can be counted or measured. Now, quantitative variables can then be broken up into two other types of variables. You have discrete variables, which are countable, so 1, 2, 3, 4, 5. It could be anything like the number of cats you have, or the number of people in your class, anything like that. It has to be a whole number. It can't be a half of a person or a half of a cat. That's just weird. Those are discrete. A continuous is something that continues. It can be a fraction, a whole number, or a decimal. We usually associate it with a ruler because you can have inches and centimeters, and you can have half an inch, decimal inches, stuff like that. So anything that can be in between whole numbers can also be continuous. You can measure the height as continuous. You can measure weight as continuous. I don't know, miles you ran, something like that. Okay, so here's a little picture image for you of how data is set up. Again, you can have it either qualitative or quantitative, and underneath quantitative, it's either discrete or continuous. Here are some more examples on the side here. So in categorical data, in qualitative data, we have a type of sports and we have food groups. But over here in quantitative numerical data, we have some things like height and weight and salary and distance from work or home or hours per week that you're working. In here we also have some categorical data like name, contact number, postal code, education level. So we're going to take a second and see if we can figure this out. Can we decide if these are discrete or continuous? So I can already tell from it. I don't know if you can or not, but anything that says number of is going to be discrete because you can't have half a broker or half of an apple on a tree. I mean, you could, but you can't really. And then everything else, hours, weight, will be continuous. Let's see how we do this again. So if we were going to do this, we can move hours watching YouTube. I'll just put letters over here. So discrete would be, never mind, you know. So A and D, hours and weight, are continuous, and B and C, numbers of something, are discrete. Okay. Now, while you're collecting data dealing with continuous variables, you also have something that's called class boundaries. So if I'm talking about the height of a person, in order to look at that data on a graph or a chart, it's going to be easier if we group those people into classes. So the class boundary will help us when we're setting up our classes. You usually do 0.5 before your class and 0.5 after. So instead of looking for people who are 6'5", you would look for people who are 6.49 and 6.55 or something like that. You always go 0.5 above. I think I have a couple examples here. Yeah. So the class boundary of 112.3 pounds is 112.25 to 112.35. And that's just because continuous variables are infinite, and we want to make sure there's no gaps between our classes as we're setting them up. Here's another one for the temperature. Temperature is also a continuous variable. So instead of looking for just 73 degrees Fahrenheit, we go 0.5 before and 0.5 after the 73 degrees Fahrenheit. Okay, now that you know the difference between these two types of data, we can show you how to organize it or scale the data. There are 4 different types of scales, and they build within each other. So something that's ratio is also interval and ordinal. Something that's interval is also ordinals. So it's good to keep in mind that you always want to check each one and make sure that it doesn't belong into a higher scale than what you think it does. So we have nominal, which is classifying data. It has everything to do with categorical. Categories. Well, I don't know why I can't say that word today. So some examples are the person's favorite color, and like the car that they drive. Ordinal data, we can actually order it. We can rank it. So first, second, third place. I did better on this exam than you did, so I can actually order those numbers. And it's going to be, or categories also. Then you get into interval data. These can be ranked also, but there is no real meaning to the number 0. So biggest one that we use in interval data is temperature. 0 degrees Fahrenheit does not mean no temperature. Then ratio is the highest level that we'll look at. Ratio can be categorized. It can be ranked. It can have a real 0. So that's the major difference between interval and ratio. So if I have no grains, I have no weight of grain, right? If I have no money, I have no money. It's not the middle point on a scale like interval is. So like think of interval as the number line. I can go negative and positive, but ratio 0 actually means something. Also with ratio, I can say I have twice as much, or my score was twice as high as your score on something. You can actually make a proportion with ratio data. Okay, let's see if we can do this. So we have 4 options here. We have pizza size, age of participants, zip code, and SAT scores. So which one is nominal, ordinal, interval, and ratio? Okay. So let's look for the nominal data. Pizza size can be ordered, so it's not nominal. Age of participants, well, I can be twice as old as somebody else, so again, not nominal. Zip codes, zip codes are a number, but it doesn't make sense to say that my address or my zip code is bigger than your zip code. I can't order it. So it has to be nominal. So I can move my zip codes over here. I'm struggling. There we go. Okay. Let's go back to pizza size. We found out that pizza size can have an order, right? I can have small, medium, and large. Let's see if it makes sense. I don't think it makes sense to say that pizza size can be an interval, because you can have no pizza. I can have a small, medium, and large. It doesn't really make sense to compare. I'm going to say it's ordinal. Okay, age of participant. So let's see, I can order our ages. I can, 0 is a real age of participant. So it's not interval, but it is ratio. Okay, and then SAT scores are interval because 0 SAT score is not really a thing. But it's also not really a thing to say that 1300 is twice as good as like 650 or anything like that. But I could say that like 1450 is 200 better than 1250, something like that. But it's not, doesn't make sense to say my score was double your score for SAT scores. Okay, here's another example, and I'm going to show you that things like, this is some of the stuff that we already talked about, but you'll see that in some columns, sorry, you can't see what I'm doing. For example, let's look at this age again. We can say, yes, it's nominal. Yes, I can order them. Yes, I can say that I'm 20 years older than you. And yes, I can also say that I am 2 times older than you. Same thing with height. I can say that I am a foot taller than you, or I could say that I am twice as tall as my car or something like that. But ACT scores, just like SAT scores, doesn't make sense to compare yourself. Like I got twice as many as you did. That doesn't really work because of the point scale. Same thing with a letter grade. But funny, in a letter grade, you can order them A, B, C, D, but just giving a letter grade instead of a number grade, you can't say that I have 3 more points than you. So they do improve on each other as you go through the scale. So just keep that in mind. Yes, temperature is ordinal and nominal, but at most it's interval. Okay,